The methane and methyl alcohol, both molecules are having covalent bond. There is no pi bond in this. Covalent bond means sigma electron, these two also sigma electron, these two also sigma electron, these two also sigma electrons. You see here, these two sigma, sigma, sigma. Okay. This is a covalent bonding electrons we are indicating with sigma. Okay. And only sigma. Here on oxygen, we are having non-bonding electrons or lone pair of electrons we are having. That means that is n electrons it has. N electrons it has. Okay, oxygen here like a water instead of hydrogen, just we are keeping methyl here. This sp3 hybridization, we are having two more lone pairs on oxygen. Those electrons we are naming it as non-bonding electrons. Similarly, if you are having this carboxylic acid, okay, what will be the carboxylic acid? What type of electrons it will be having? The carboxylic acid will be having sigma electrons as well as phi electrons. See that? Let us take simple formic acid. Okay, formic acid. Now, formic acid is having what type of electrons? We are having sigma electrons and we are having sigma electrons as well as phi electrons here. One phi bond is here, one sigma bond. Sigma electron, sigma electron, sigma electron, and phi electron. Okay. So now how many types of electrons we are seeing? Mostly sigma electrons and phi electrons. Sigma H I J K L M N Q R S. Yes. Okay, in Greek language, sigma means yes. Okay. In symbol, if you sigma electrons and P, pi electrons. Okay. This type, we are having two types of electrons in these molecules. Okay. We know already molecular orbital theory. This, what is our molecular orbital theory will tell us if sigma electron is there means there will be sigma star also. That means sigma bonding electron and sigma anti-bonding electron. We know already the molecular orbital theory, the simple concept we have already applied for hydrogen molecule. Now, sigma and sigma star. What is sigma? It is a bonding electron. Okay, we can write it is sigma, let us, and one more is sigma star. Okay, sigma and sigma star. Sigma and one more is sigma star. Okay, we are writing star and we are keeping this superscript. Okay, sigma and sigma star. What is meant by sigma star here? This is anti-bonding molecular orbital. Okay, this is what? Anti-bonding molecular orbital. This is ABMO. What is that? ABMO, anti-bonding molecular orbital, as per our MO theory, molecular orbital theory. That's what we have discussed in first chapter. Okay, so now we are applying that into our second chapter. Okay, that same the knowledge, the previous chapter knowledge, just we are applying into the second chapter. You see that sigma and sigma star. And similarly, the phi and phi star. And one more is non-bonding electrons. We have seen three types of electrons: sigma, phi, and non-bonding. N, we will indicate them with N. Okay. Yes. This entire thing we will shift it to next page, and it is easy for us to write now. Okay. Sigma, sigma star bonding and anti-bonding, and phi, phi star this is phi bonding molecular orbital. What is this? This is phi bonding molecular orbital. That means it will form a phi bond, but it is a BMO. And then the next one is phi star. Okay. This is phi star. Okay. This, and now this is N, non-bonding electron, simple N. Okay. How many types of electrons we are having in present mole? What the examples which we have seen? Sigma, phi, and non-bonding N. So we can write simple examples. Sigma alone. What are the examples? All alkanes. Sigma electrons. Sigma electrons, what are the examples for molecules? Okay, sigma electrons molecule: methane, ethane, propane. We don't have any other electrons. Okay, all alkanes. What we can write? Alkanes. Okay, sigma electrons only we are having in that molecule. Suppose if you are going for 5 electrons, 5 electrons, simple oxygen also will come. Yes, you see that. Not only so oxygen, simple oxygen, ethylene, okay, ethylene, acetylene, all other unsaturated molecules, even 5 electrons, carbonyls, that means formaldehyde, this type of thing. Okay. And n electrons. N electrons means non-bonding electrons, where we are getting alcohols, ethers, wherever we are seeing, just these are the examples for these electrons and the corresponding molecules. Okay. Now if you are taking, suppose, methane molecule, what will happen? These are all electronic transitions. We are not discussing all the transitions at present. We have to. We are concentrating only on electronic transitions. That means electron will jump from sigma to sigma star. There is no 5 electrons in methane. There is no n electrons in methane. So we can see only sigma to sigma star transition. That means electrons can jump from ground state to excited state, that is sigma to sigma star. In which type of molecules? Only in alkanes. Where we can see this type of molecules, only in alkanes we can see. This is what sigma to sigma star. Okay. What type of molecules will undergo sigma to sigma star transition? Alkanes. Mostly all alkanes, methane, ethane, there is no n electrons and 5 electrons in alkanes. That means methane, ethane, propane, butane, hexane, pentane, okay, everything. We can see only sigma to sigma star transition. This is electronic transition. In our previous classes, we have seen vibrational transition and rotational transition, but we have not discussed this electronic transition. Now, the electronic transition, this is an highly energetic electronic transition. Within electronic transitions, we are having vibrational as well as rotational. Now, we are concentrating only on electronic transition. Sigma to sigma star transition. What is this? This is the one transition, that is sigma to sigma star. So we can indicate it with a different color and even with a different thickness to understand. What is this? Sigma to sigma star. Okay. What is this transition? Sigma to sigma star transition. Why these electrons are not going to the other? We are having certain selection rules. We are having certain selection rule. What is meant by this selection rule? Sigma electrons will not enter into 5 or 5 bonding 5 electrons. 5 this thing, BMO or ABMO. See that sigma electrons can jump into 5, or sigma electrons can jump into N and 5 star or sigma star. Now, why the sigma electrons are going only to the sigma star? Because of the symmetry. Sigma electrons will be going to only sigma star, corresponding anti-bonding molecular orbital, not other anti-bonding molecular. Symmetry. Symmetry will play a major role in this, and it is a general rule. Okay, we can we can enter into our own house, not in others' house. Okay, that is what this simple thing. Sigma electrons will enter into sigma star. Okay. Similarly, 5 star, 5 to pi star. Let us see the 5 to pi star transition, where it will happen. Okay. All these things will happen in organic molecules. That's what we are discussing little bit organic chemistry at this point. Okay. So now, see the difference between this and So what is this? Phi to pi star transition. What is this? Phi to pi star. Phi to pi star transition. Phi cannot enter into the sigma. That is in selection rule. This is what, if you are studying the electronic transitions, what is this? This is an electronic spectroscopy. What is the name of this spectroscopy? Electronic spectroscopy. This is phi to pi star transition. Okay. Directly just why this and moreover why these electronic energy levels are in this order. That is a big story we have to discuss if you want to. It is not necessary, I feel, for you. Just you can remember the order of the energy levels will be like this. Okay. Pi to pi star. And these are non-bonding electrons now. N electrons can enter into phi star as well as sigma star. That is what the beauty of N electrons, non-bonding electrons. I told you what is non-bonding, and this is ABMO, okay, phi ABMO, and this is phi BMO, okay. And this is non-bonding electrons. Non-bonding electrons. Non-bonding electrons means it won't uh, involve in bond formation. They will be simply in the form of lone pair on oxygen heteroatoms. Okay. See, just non-bonding electrons can enter into pi star, and non-bonding electrons can enter into sigma star. Okay. Now we will write it with different color because we have to distinguish it. So we will write it with blue color, that is N to pi star transition, okay, with okay, and this is N to pi star transition, and this one with one more color, just a pink color, we will select, and we keep it with 1.75. Yes. Okay. Just 4 types of transitions we are seeing in organic molecules. These are the electronic transitions possible in this is N to pi star transition. Okay. What is this? This is N to pi star transition. And another one is N to sigma star. How many transitions are possible in organic molecules now? The N to sigma star. 4 types of transitions we are seeing at present in organic molecules. N. So just it is not new N. It is not nu, it is n, small n. Okay, n to sigma star. Four types of transitions. Okay, four types of transitions. Sigma to sigma star and n to pi star, pi to pi star, and n to sigma star. Now, with respect to energy, we have to discuss this. Which electronic transitions are coming in which range? What is the energy required for this? This is the energy, okay? This is the energy level, and sigma to sigma star requires high energy, and moreover it will happen in vacuum UV. What is meant by vacuum UV? 100 to 200 range. This is below 200. What is this? This is energy. These are the electronic transitions. And now we can give these are the electrons first. These are the molecules which are having these electrons. Now what we can give examples for these transitions. Sigma to sigma star transition. Find out the molecules. Methane, ethane, propane, butane, hexane, pentane, this type of molecules will undergo sigma to sigma star transition. But this sigma to sigma star energy is very high. It will be coming below 200 nanometers. We know already the UV visible range. What is the UV visible range? 200 to 400 is UV. 400 nanometer is UV. Okay. 400 nanometer to 800 nanometer is visible radiation. Okay. Now below 200, that is, we will be naming it as vacuum UV. Below 200 nanometer. And our UV visible spectroscopy, if you want to, UV visible spectroscopy is an electronic spectroscopy. Okay, both are same. And now if we want to study UV visible spectroscopy, what is the range? We have to supply the electromagnetic radiation which is having this wavelength, that is 200 to 800 nanometer. Below 200 means that sigma to sigma star we are not interested, and moreover this is highly energetic and bonds will break. Okay, bonds will break. That is highly energetic. Okay, we know the order gamma ray, X-ray, UV. After X-ray, UV is there. That means highly energetic means it may go to the X-ray level, X-ray energy, X-rays energy level. Okay, in that case what will happen? Molecule will break. And moreover, we are not interested in sigma to sigma star because we are interested in which electronic spectroscopy? UV visible spectroscopy. We are interested in UV visible range. That means sigma to sigma star also not coming in this range. Now, similarly, N2 sigma star. This is also highly energetic. This is also coming in the same region, near 200, 180 or 200 or 210 in that range. That means these both electronic transitions are highly energetic and they will be going below UV radiation range. And now, which are the transitions which will be coming under UV visible spectroscopy now? These are the two transitions, that is phi to pi star and n to pi star. These are the two electronic transitions which we are going to study in UV visible spectroscopy. Okay. The interaction of UV visible radiation with matter is known as UV visible spectroscopy. Interaction of microwave radiation with a sample is known as a microwave spectroscopy. Interaction of infrared radiation with a sample is known as infrared spectroscopy. The interaction of UV visible radiation with sample is known as UV visible spectroscopy or electronic spectroscopy. In electronic spectroscopy, what happens? Electronic transitions will occur. These are the electronic transitions. Okay. This electronic transition and this electronic transition both are highly energetic, and they will be coming below 200 nanometers. And anyway, we are not interested in this range because we are interested in UV visible range, not below UV range. That means these two transitions are now we are not going to study. We are going to study only pi to pi star and n to pi star. Okay. Sigma to sigma star and n to sigma star. So we are not going to study. Now we are going to study only n to pi star and pi to pi star transition. These are the two electronic transitions which we are going to study. Pi to pi star transition. What type of molecules will? The ethylene, acetylene and formaldehyde, this type of molecules will be going, mostly alkynes will undergo pi to pi star. N to pi star means we should have an heteroatom. See the difference between N to pi star and let us take benzene molecule. Benzene molecule will undergo what type of the electronic transition? Benzene will undergo only pi to pi star transition because it doesn't have n electrons. All are 5 electrons only. 5 electrons means it will undergo pi to pi star transition. By seeing the molecule, we can tell now which type of electronic transition it will undergo. Okay, benzene will undergo what type of transition? Pi to pi star transition. Cyclohexane will undergo what type of transition? Cyclohexane means similar to the benzene, but it doesn't have a double bond on its ring. Okay, this will undergo sigma to sigma star. This will undergo pi to pi star, and we can write so many other examples. And simple phenol, let us take phenol or benzaldehyde. We take benzaldehyde. This is a benzaldehyde case. What will happen? Just what type of transitions it will undergo? Benzaldehyde will undergo pi to pi star, it will undergo. Benzene ring will undergo pi to pi star, and it will also undergo pi to pi star, as well as oxygen is having n electrons, non-bonding electrons. Non-bonding electrons means there is a chance for n to pi star also. That means benzaldehyde will be undergoing two transitions. What are those transitions? N to pi star electronic transition and pi to pi star electronic transition. And simple methanol. Methanol will be undergoing only sigma to sigma star. No, even not even n to sigma, and n to sigma star also there is a chance for n to sigma star. And anyway, we are not interested in that because that will be coming below UV range. Okay, CH3OH. This will be undergoing sigma to sigma star and n to sigma star. Okay, non-bonding. And we can write a few more examples simply. Simple oxygen. What type of transition it will undergo now? Oxygen has 5 bond. Okay, and oxygen has sigma bond. The pi to pi star transition or n to pi star transition. 5 bonds are there, and Oxygen has non-bonding electrons, and even instead of one oxygen, if you are keeping a carbon, what will happen? Okay, that is formaldehyde. Okay, formaldehyde molecule, what type of transitions are possible in formaldehyde? Sigma is there, sigma to sigma star, N to sigma star, and 5 to pi star transition possible, N to pi star also possible. Okay, the four electronic transitions. Okay, and sigma to sigma star, N to sigma star. So we are not interested. We are interested only in N to pi star and pi to pi star because they are coming only in UV visible region. Okay. This and I have discussed one important thing in introduction to quantum chemistry. Why tomato is in orange? Why this carrot is in orange color? Why tomato is in red color? This is the reason now. You see that because of these electronic transitions, the carrot is in orange color. Why that carrot will be having what type of electronic transition? Pi to pi star electronic transition. Similarly, tomato, which electronic transition it will be undergoing? Pi to pi star electronic transition. Because of the lycopene. Lycopene, the tomato will be having a red color and the carrot will be having orange color. Why? They will be having that color. They will be undergoing this electronic transitions. These electronic transitions range is in that range, VGR range, that is in visible range. That's what we are seeing them in color. Okay, this is the explanation. See that in order to understand these concepts, we have to understand first the quantum chemistry. Okay, if you understand the quantum chemistry, we can understand these things. Okay, these are the electronic transitions, four types of electronic transitions, N to sigma to sigma star, N to sigma star, N to pi star, and pi to pi star. Okay, with this